I've been working with these machines for over a year now, and I've tried my hand at quite a few projects. Like a lot of hobby machinists, most of these builds are more tools for the shop, but I did have a few other things sprinkled in here and there. Each one came with a new technique to learn or challenge to overcome, so it's safe to say I've spent a great deal of time getting familiar with this equipment. And familiarity breeds contempt. Okay, maybe that's putting it a bit harshly. I do love these machines. But there are some things that could be improved upon, especially on the lathe. I've even gone so far as to make a list of the things I'd like to address. So today, that's exactly what I'm going to do. My list is far more extensive than I could possibly cover in one video, so I'm just going to start with the things that bug me the most and we'll see how far I get. To begin, I'm actually going to revisit a past upgrade I did for this lathe. Last year I made this tool post locking handle to replace the hex nut that was originally here. This nut is what prevents the tool post from rotating once you set it at the angle you want, which in most cases is just getting it square again after having set the compound to a new angle. My hope was to eliminate the need for hauling out a massive wrench every time I needed to make an adjustment. But after extensive use, I discovered my supposedly clever handle couldn't quite get the leverage needed to lock everything down for the heavier cuts. So I have to bust out the wrench anyway. Fortunately, I thought to include the wrench flats on the new handle just in case this was a problem. But that's not all that's wrong with this setup. When I go to tighten the tool post, the friction under the nut actually causes the tool post to rotate from its setting. I can usually mitigate this by resting the post against a square reference as I tighten it, but it's still annoying nonetheless. So here I have a supposed upgrade that doesn't really solve any of the problems it was originally supposed to. Needless to say, I'm not very pleased with this. But there is a somewhat easy fix. A thrust bearing. By using a thrust bearing under the nut, I should be able to make the joint nearly frictionless. This should eliminate both the holding force and rotation problems I'm having. But like any good project, it's not exactly as simple as just plopping this under here. I'll need a way to keep this bearing both centered and shielded from debris, so I actually get to make something. I'm also going to skip the drafted drawing on this one. A simple AutoPAD rendering should do. It's basically just a shallow cylinder with an annular groove, where the inside hub centers the bearing elements and the outside acts as the debris shield. I also want the locking handle to stop in the same location as it currently does, so as long as I make the thickness a multiple of the 2mm pitch on the threads, it should work out perfectly. Simple enough, so let's get to work. I'll save myself some setup and just use this offcut from another project. You know, actually, I think this is the offcut from the tool post nut project itself. It's almost like the universe was trying to tell me something even back then. I'll get this chucked up on the lathe using the leftover step on the end. Then I can begin shaping the outside dimensions, first facing the end, then turning down the OD. Since the ID is already drilled out, I can move right on to boring this to a clearance diameter for the threaded tool post. Then it's time for something a little more interesting, like trepanning. Ooh. I made this trepanning tool in my last video for a similar operation. And since the diameter of the groove I need to cut in this face is larger than that in the previous one, it will work here as well. I'll get a touch on the outside diameter and on the face of the part. Then I can engage the power feed and begin cutting the groove. Is right, Mr. Brandon. Got a little cocky there, didn't you? And on several accounts, I might add. Not enough grip in the chuck, aggressively power feeding the tool, and no lube? This was bound to happen. And now not only is the part scrapped, but so is the tool. Now take your shame over to the boss. Actually, hang on one second. I think this is salvageable. I've still got plenty of material to work with here. I'll take a little more precaution this time though, and remove that flange to give myself a larger area to grip on in the chuck. Switching to the forejaw would be the best for recentering the material, but that's a whole ordeal. So instead, I'm going to see if I can get this running true without swapping chucks and going through that whole alignment process. The chuck jaws should get it reasonably close to centered, but to take it the rest of the way, I'm going to use the highly technical approach of mashing a metal bar against the diameter while it's rotating. It may have been hard to see on camera, but that visibly straightened out the stock pretty well. And the indicator agrees. Within 0.02 is more than acceptable for this part. From here I can just face away the little whoopsie from before and nobody will be the wiser. But I still have the broken trepanning tool problem to address. So, I guess I'll have to just make a new one. Good as new. I'll get this squared up in a tool holder and I can try this once again. This time I'll do all the feeding by hand and properly lather this thing up in cutting oil. Much better. Despite my little self-induced mishap, I still maintain that this is one of my favorite operations. It's just so satisfying watching those thick curls roll out of the groove. The final groove requires 2 passes with the tool, which leaves just a thin wall on the outside for the bearing debris shield. Let's see how the bearing fits. Yep, that's pretty much perfect. It's properly centered, and the bottom race protrudes from the part a few thousandths just like I need. Nothing left to do but to part this off. And after a light deburring, we can see if this is going to work. Now that is nice. It certainly feels like I'm able to get it a lot tighter for the effort I put into the handle. Plus the post no longer rotates from its position when I crank on it, and the handle stops right where I want it to. It's nearly perfect. There is just one more thing. Okay, now it's perfect. I'm actually amazed how much nicer this feels. It's kind of hard to put into words, but the action just has a certain quality to it that makes me more confident in its holding power. My only wish is that I would have thought of this during the original lever build, so I could have made it all in one piece. Of course, hindsight is 20/20. I'm really happy with how this turned out, but it's only one improvement on a list of many. So what's next? Oh yeah, let's do the old compound slide dial indicator upgrade. So here's the problem. The compound slide has its own hand wheel and dial, but they leave a bit to be desired. The dial has 1 thou increments, but because it's such a small diameter, the marks are really close together and can be difficult to see. This isn't a big deal in its own right, but they also seem to be somewhat inconsistently spaced, which doesn't exactly give me the warm and fuzzies. Actually, dropping an indicator on here, I just discovered another issue I wasn't aware of. Every revolution of the hand wheel should be a distance of 200 thousandths. But I'm only reading 199 thousandths. And this holds true for every additional revolution. This can only mean one thing. The pitch of the lead screw inside is wrong. How on earth I've made it this far without realizing this is beyond me. The last qualm I have about this whole situation is that there's a great deal of backlash in the lead screw and no way to adjust it. This is manageable as long as you know it's there, but it's not exactly pleasing to work with. So yeah, I've got some problems that raise the question of accuracy on the compound, but what am I going to do about them? Well, I use the dial indicator to measure the true position of everything, so why not make a mount to properly place a dial indicator on here a little more elegantly. This will need a bit more processing power than the old AutoPAD can handle, so I'll do a proper drawing on the drafting table. To start, I don't want this thing to be a permanent attachment on the lathe, and I'd prefer it to be easily removable. A rectangular cutout on the body will saddle the compound slide and clamp onto either side. This also makes it adjustable, which is nice since the stroke of the compound is a lot larger than that of the dial indicator. The clamping mechanism is formed by a slit with a cross hole through it for a simple thumb screw. The indicator will mount on the opposite end through a bore that accepts the 3/8 stem, and it's clamped in place with a similar slit and screw mechanism. Lastly, on this part, I'll include a sort of scalloped grip area to make it a little easier to handle. But if I'm being honest, it's just to make it look cooler. The screws will be a 2-piece design with a knurled knob press fit onto a custom threaded stud. This not only saves on material, but lets me make the knobs out of brass for added cool factor. The final thing I need is a flag that mounts stationary on the machine and gives the dial indicator something to measure to. Okay, this will be a little more work than the previous upgrade, but I'm looking forward to some of the operations to come. I'll get everything dimensioned and I can get to it. I had a lot of design freedom on this one, so I intentionally sized everything to work from materials I already had on hand. I'm going to start with the body since, well, that seems the most interesting. I'll get this bar cut down to an appropriate length, and I can head over to the mill for the fun stuff. Wait, what's wrong? Oh yes, that. How could I forget? So yeah, last video I had a little issue with the slitting saw arbor I made. If you stuck around to the very end, you got a little bonus clip of, well, this. The arbor is completely jammed in the mill. What I didn't show you though was how this happened. I took several cuts with the slitting saw other than those I showed. But on one test, I wasn't quite as liberal with the coolant as I should have been, and the blade completely seized up in the material. It was so bad in fact that it actually stalled the motor. How the blade didn't also break is beyond me. Anyway, my guess at what happened is that the key pin in the spindle mashed its way through the side of the keyway in the saw's R8 arbor and is now bound up. So I basically need to twist it back so I can drop it out of here. Maybe if I would go the right way. Oh god, you dumbass. It's going the wrong way. Ow! Ouch. Well, despite my best efforts to keep this thing looking decent, it didn't make it out without a few battle scars. But those are only cosmetic. The real problem is on the keyway. My suspicion was right about the pin bulldozing its way around the arbor. I'm not exactly sure what I'm going to do to fix this yet, or if it needs fixing at all. But I know one thing for certain. This is a real kick in the nether regions. I was really proud of this one too. I could wallow in regret all day, but I came to the mill to do a job, so might as well get to work on that. I'll start off by squaring up this stock and getting it to dimension. This isn't strictly needed on the long faces of the stock, but I'm a sucker for a nice fly cut finish. I'll get this remounted and begin work on the finer details. First, a simple rabbet on the indicator end of the bar. Then after switching to this bevel mill, I can start dropping chamfers on the part. 2 on this end, then 1 on top and bottom of the other end. Because, well, you know. That takes care of some of the cosmetics. Now to move on to the functional bits. After spot drilling for the indicator hole, I'll use that pivot point for the divider to scribe the round I'll add to this corner later. Then continue on drilling and reaming the hole, making a nice precise fit for the dial indicator. While I've got the bar on its side like this, I'll also knock out the scalloped grip areas with the ball end mill. Like other cutters where you're working with variable cutting diameters, there isn't really a way to perfectly dial in the speeds and feeds for this tool. This is especially true for ball mills like this, where at the very tip the cutting speed is 0, so it ends up just plowing its way through the metal rather than cutting. Technically I could tilt the mill head and cutter so that I'm not cutting on the tip, but that's a whole lot of hoopla for a single, mostly decorative feature. Besides, with light cuts and a lot of coolant, I'm able to produce an acceptable finish. Before I get to the more important stuff, I also want to knock out the round I scribed before. Since it's just a single feature, I'll spare myself a lengthy rotary table setup and just shape this on the belt grinder. To finish this off, I'll smooth out the grinding marks by hand on a much higher grit emery board. Using a rotating motion like this helps keep a nice consistent radius around the corner with no flat spots. This does leave a slightly different finish than the milled faces, but I feel like that's a small price to pay for the simplicity of this approach. Back on the mill, I'll stand the part up square in the vise and work on the indicator clamping mechanism. I'll start with the screw hole, which consists of a clearance hole near the surface, and a 10/24 threaded hole beyond that. Then I'll move on to the parting slit. I still haven't figured out what I'm going to do about my poor, mangled, and beat up slitting saw arbor, but I need a slitting saw, so I'm going to see if I can make it work. I'll get the blade height set up so that it's barely touching the reference surface, then cut my way clear through to the indicator bore all in one go. That went pretty much perfectly. And better yet, the arbor has no problem releasing from the bore. But that's where the good news ends. I only just now discovered a huge error I made. The screw hole I just drilled in the end intersects with the indicator bore. Somehow I misjudged this clearance during the design. What a doofus. Looks like I'll be starting over. I'm pretty close to the end though, so I think I'll go ahead and finish this out just in case I discover any other hidden issues. The other end of the bar gets a similar clearance plus threaded hole in the end. Then I'll bring in the slitting saw once again to cut almost all the way through the bar to form the clamping element on this side. The last cuts are to make the pocket that will actually saddle over the body of the lathe compound. I'll first bring in a roughing mill to do most of the material removal, then switch to a finishing mill for the final cuts. First taking the end of the pocket to the perfect width to fit the compound, then removing the last few thou off the pocket depth. Alright, let's see how it fits. Nice. It slides freely along the top of the compound with only about 1 to 2 thou of wiggle room, which I'm hoping will be a perfect amount of engagement once I get the clamping screws on here. Actually, there's no reason I couldn't go ahead and make the screws now. I've been itching to play with some brass since I started this project, so I'll work on the knobs first. To start, I'll face the end of some stock and turn down enough length to form the 2 screw knobs from. Then it's on to some knurling. I've yet to try this newly made knurling tool on some brass, so this should be fun. I'm going to go for a straight knurl here since I really only need rotational grip on the knobs to turn the screws. And once I verify the pattern is transferring correctly, I'll send it on its way across the bar. Oh yes, very nice. Next is to form the boss. This includes a fillet, so I'll do all the cutting with this form tool I made for a previous job. And no chance this was getting by without some chamfers, so I'll break these 2 edges, then bring in the parting blade to separate the first knob. After repeating the same operations for the second knob, I'll start work on the opposite ends. First facing and chamfering, then moving on to the through bore, which gets drilled and reamed for a press fit on the screw studs I'll make next. But since I don't want those screws to just pull through as they're tightened, I'm also going to put a counter bore on this end as well. Alright, we're partway there. The screw studs are long compared to their diameters, so I'll start by facing and center drilling the end for tailstock support. Then once set up with a live center, begin turning down the main shaft diameter to be a 2 thou press fit into the knob. Once there, I'll begin single point turning the 1024 threads. But rather than take a dozen passes to get the fit just right, I'll get them close, then switch to a thread forming die to pick up where I left off. After verifying a good fit with the body, I'll bring the knob in and use the tailstock chuck to press it onto the shaft until the shoulder bottoms out into the counter bore. Then, just part it off and repeat for the second knob. This leaves the final task of cleaning up the ends, so I'll chuck these up one last time to whittle away the excess material, and also drop a decorative hollow in the face of the knobs. Now this is the point where I would normally show you how these things worked out on the assembly, but in a second wave of brilliance on this project, I completely forgot to record that before making a whole bunch of changes. But I'll do my best to fill you in. To start, the screws I made didn't provide enough clamping force to properly secure the assembly onto the compound. This was a twofold problem where the clamping element wasn't flexible enough and the screw pitch was too coarse. So I ended up remaking the screws in a finer 32 threads per inch as opposed to the 24 of the originals. Fortunately, I could salvage the knobs from the first attempt, so I was able to simply press these onto the new studs before refinishing the ends. I also went ahead and remade the main body to reflect this change as well as correct the issues from before. Obviously I shifted the one screw hole down to clear the indicator bore, but I also got a little chamfer happy on the original and wasn't a fan of how close this one was to the hole, so I excluded it on the remake. Because the hole shifted down, I also had to make the top part of the bar thicker, and because of this, I also shifted the hole on the far end down as well. Lastly was making the slit on this end just a bit deeper to give the clamping element more compliance. Which brings me to right now. So how does the new version work? It's definitely a lot easier to get the clamp on the compound and feels a whole lot more secure. I mean, it's not going to withstand a hammer blow, but it's definitely tight enough for the vibrations this might see. What about the indicator side? Oh yes, very nice. Hardly any pressure needed at all to lock the indicator in place. And it puts it in a very visible position. This is going to work perfectly. I do have one more thing to make though before I can call this project complete. I need a flag that mounts to the compound base for the indicator to read against. So it's back to the mill for one last job. I'll start like always by milling a block down to my outside dimensions, then drop a couple counterbore mounting holes on here. There are some clearances needed on the back of this, so I'll flip the block over and hog away the material with a roughing mill. I'll reposition one last time and clear the material on this side as well. Then that's it for this piece. Let's get it attached to the lathe. This one is more of a semi-permanent feature, so it will actually bolt in place. That means I need to drill and tap a couple holes into the base of the compound. And rather than break all this down to get it set up on the mill, I'll just knock these out with the trusty Milwaukee. I'll be honest, it feels insane drilling right into my lathe like this. But really, these are all tools meant to do a job. So anything that makes those jobs more effective is okay in my book. Cordless drill or otherwise. With the flag mounted, the indicator now has a reference to read against as I traverse the compound. And because the indicator mount is adjustable, I can get it right where I need it for the stroke of the compound. I'm going to go ahead and say that this upgrade will definitely make my machining more effective. Now I have a reliable way to bypass the questionable hand wheel dial, meaning I can achieve higher levels of precision. That is, as long as I don't have any more brilliant moments. Plus, I'm pretty pleased with how cool this thing looks. It's like a little bit of jewelry for the lathe. In addition to this, I also finally solved my tool post locking lever problem. No longer will I have to worry about whether my tool post is tight enough or truly at the angle I set it to, which will certainly make my doings at this machine more effective. Despite a couple do-overs, I'm really pleased with the outcome of these upgrades. Sure, I only crossed 2 items off my list, but they were 2 things that were really bugging me. Plus, this just means I have more projects for the future. As always, thanks for watching, and see you next time.